So once you determine the LCD, each term gets multiplied by that LCD, meaning even if there is a term that does not have a denominator, you still have to multiply it. So now what cancels here? Between the 24 and the 24, right, those go away. From the second one, the 3 minus x cancels with the 3 minus x. And from the last one, the 4 and the 24 reduce, so you have a 6 up there. Making sense so far? Are we okay? Yeah. Now, let's just write things out. So first I have 5, 3 minus x, plus 2 times 24, equals 6 times 3 minus x. So what this did is it got rid of the denominator. It's now just a simple algebraic equation, and now we could simplify and solve. So the 4 and the 24 reduce to 6, right? It was 24 on top, 4 on the bottom. They divide to 6. Okay? So I have 15 minus 5x plus 48, 18 minus 6x. All right? Here, the 24s cancel. So I have 5 times 3 minus x. Right? So I first multiplied each term by 24 times 3 minus x, right? And there was a 24 on top and bottom, so they canceled. Okay, so now I have 15 plus 48, which is what? 63. So minus 5x plus 63 is equal to 18 minus 6x. I add 6x to both sides, so I get x equals 18 minus 63 is what? Negative 45, right? Okay. Are we okay? Now, it says to check your solutions. We need to be careful that we don't get the restriction as a solution, all right? Which in this case we didn't, so we're good. Yeah. Okay, so here I have x plus 3 and so on and so forth. All right, so any restrictions?
Yeah. Oh, wait. No.
None, right? Because there are no variables in the denominator that could potentially equal to 0, right? Yeah. Well, if I've asked you, yeah, say that there are no restrictions, just so I know that you've checked and you've determined that there are none, okay? Versus you just forgot to check. Okay.
What would make it a restriction to 3?
Where?
If x is 3.
For this problem, B? Or A? Yeah, for A, the red one is the restriction here. So the restriction is that x cannot equal to 3. So you're restricted in that any number is fair game except for x equals 3.
And there's no restrictions in B.
Because there are no variables in the denominator. Okay, so now what's the LCD? It's 18.
Wait, then how come it's 24 times 3 minus x? How is 24 also a restriction?
It's not a restriction. The restriction is just in the red.
Oh, okay.
Then the green is the LCD. So the LCD between the 6 and the 18 is 18. So now I multiply every single term with the LCD, right? Even if some of them don't have fractions. Okay? So go ahead and write down what this turns into. So what do we get here? 18x plus 54 plus, is it 15? 15 equals 23. Okay, so we're going to be doing some of the canceling. So now I have 18x plus 69 is equal to 23. 23 minus 69?
Negative 46.
And what do we get when we do that?
Negative 23 over 9 is all you can do.
Negative 23 over 9. Okay? Awesome. Okay. Now, extraneous solutions. We've come across this term before, right? When we were solving the logarithmic equations. What are extraneous solutions all about? Solutions that aren't true. And where do they come from? If you get two answers, or if you get, more than the necessary amount of answers, they usually come, these are solutions that most often are artificially introduced to a problem because you multiplied the equations by something, you squared both sides of the equation, you took the logarithm of this, and so on and so forth. So that's where it comes from. So, so this is a solution that does not make the equation true. So here we go. Let's take a look at this one. All right, so step one, we're going to factor anything in the denominator that can be factored. And let's just factor the numerator as well. So here we have x plus 3 and x plus 5. Huh? Right, we have to do restrictions. So I do restrictions after I factor. The denominators are going to go away, so let's just leave the numerator as is. What are the restrictions? So x can't be negative 3 or negative 5.
Wait, my page looks like a lot different. Oh wait, never mind.
Okay, so the LCM is what? X plus 3 and x plus 5, and I multiply everything by x plus 3 and x plus 5. Okay, so what cancels from the first fraction? Right, and from the second? Both, and from the third? X plus 3. So 2x x plus 3 minus x squared minus x minus 10 is equal to 3 x plus 5. All right, so I distribute. I get 2x squared plus 6x minus x squared plus x plus 10 equal.
Minus x squared minus x.
You're sure?
Did we not back to the top?
Oh, you distribute.
Huh?
Did we back to the top? Why are you distributing it up?
3x plus 15. So here I have x squared. 6x plus x is 7x. All right, let's combine. Okay, are we good with this? Yeah? So x plus 5, x minus 1 is equal to 0. And here we get x equals negative 5 and x equals 1, but it can equal negative 5, so the answer is just x equals 1. Okay?
Oh, so if you know that that's
Right.
restriction, you don't even need to check.
Exactly. Okay? All right. So what about here?
I have a question.
Yes.
The 3x on the right side, how did you get rid of it and make it from 7 to 4?
Huh? Oh, I subtracted 3x and I subtracted 15. So I subtracted 3x and 15 later. So now, let us factor this one. This is a fun one to factor. Right? I know. So what are the restrictions? N cannot be -1 or +1, so I can write it like this. Or I can say n cannot be +or -1. Okay?
How'd you figure that out for the restrictions?
Because take a look at each of the parentheses. In this one, if n was -1, +1 would make it 0.
Oh, right.
So the official way is you take each parenthesis, set it equal to 0, and solve for n. Right? So n + 1 = 0, n = -1.
Okay.
I know I should have mentioned that before. Sorry. Yes.
So it's for the middle one though, can't -1 and -1 -1 is
Right, -1 works for that one. That's fine, but 1 doesn't work for that one.
right for all.
Yeah. As long as it makes one denominator 0, it's a restriction. Okay? All right, so what are we going to multiply all this by? Between the 3, the 4, and the 12? Huh? N + 1 goes away. And what about the 12 and the 3? 4. N - 1 goes away, and we have 3, right? Is that right? Yes or no?
Yeah.
And then the n + 1 goes away, and we have a 6. So now I have, this is where you have to be like careful because you've got all these, like messy crossing outs and so on and so forth. Okay, so 4 times 7n times n - 1 minus 5 times 3 times n + 1 equals how much? 6 times 3n times n - 1. So 28n n - 1 minus 15 n + 1 equals 18n n - 1. All right, we distribute 28n squared minus 28n minus 15n minus 15, 18n squared minus 18. Huh? Yeah. Okay, so actually at this point I'm gonna leave you to finish it. So I'll stop this for a second. 10n squared, is that right?
Yeah.
And then how many n?
25, -25 minus 15.
Okay, so what can we factor out of all of this? A 5. And we get 2n squared minus 5n minus 3. And can we factor that further? Yes? So let's see. So if we get a -3 here, we make a -6n here, plus 1, that'll be a -5n, right? So n is -1/2 and 3. Okay?
Why is it not?
Wait, go back up.
Yeah. Huh? Huh? So there are two answers, -1/2 and +3. Neither of them are restrictions, so we're good to go.
Wait, but you don't do anything with the 5?
No, because the 5 will divide out, right? So you can divide both sides by 5 and it'll go away. So when we get to this point, what we do is we just set the binomials with variables equal to 0. Okay, so let's do this next one. We're gonna factor this. What do we get when we factor? Z minus 1, Z plus 1, and the restrictions are plus or minus 1. All right, so you're on your own with this one. I will pause this. So when you solve, you get that Z is equal to 1, but that's one of the restrictions. Z cannot equal to 1, so we say no solution.
Even if you got -1, that's only the solution.
So we say no solution, or you either write it out or it's an empty set. empty set, that circle with the, that's called an empty set, okay? So it's, is it negative 1? It's 1. You got z equal 1.
No, it's positive 1 because.
Right, z equal 1. Okay. So, so weighted averages is what we're going to talk about next. So if you have, let's say you have 3 test grades, right? You get a 95, a 90, and then a 92, okay? And you want to take an average, what do? You add all of these and you just divide by 3. That's a simple average. A weighted average is how we calculate your overall grade. So for example, your test grades, count for 50%, and your quiz grades, let's say, count for 30%. And for the case of simplicity, let's say you had something else that counted for 20%. So now let's say all of your tests together averaged 93. All of your quizzes together averaged 95%, okay? And all of, like everything else, let's say it was like the homework, it averaged 90%. To calculate your final average, it's 50% times 0.93. So 0.5 times 93, 0.3 times 95, 0.2 times 90. So the thing is, the 50% category has a greater impact than this, and that has a greater impact than this, versus a straight average where all of your tests have equal impact in that category. Do you see what I mean? So that's what a weighted average is. And we come across it all over the place in chemistry. We come across it all over the place in other applications. So here is another one. So Jimmy has 15 milliliters of a drink. That's 10% fruit juice. All right? So it's just a concentrated, it's a diluted mixture, and it's 10% fruit juice, 90% something else. We really don't care what it is. Now he's got another solution that has 65% fruit juice, okay? Now the question is, how much of the 65% solution must be added to create a fruit punch that is 35% fruit juice? So in my initial container, right, I had 10% fruit juice. I need to make it stronger so I get 35% in the end. Okay? So how are we going to do this? All right, so there are 2 things at play here. One is the amount of juice, right? And then the total solution. So in the original, right? So in the original, I have 15 milliliters. That's my original. Is everybody following? I have 15 milliliters, and it's 10% solution. Okay? So how much of actual juice do I have? 15 times 0.10. Yeah. Okay? Now, to this, I'm adding the 65% solution. And the question is, how much of this should I add? Okay? So, how much am I going to add? I'm going to add 65%, and the amount is going to be x. So 0.65 x. So the new mixture is going to have 15 times 0.10 plus 0.65 times x. Okay? So this is just the amount of juice. It's the good stuff in the solution, the juice. In the 15 milliliters, 10% of it was fruit juice. I added 6x milliliters of the 65. Now together it's this. Okay, you're more than welcome to wait outside. Okay, so now the total solution, what's the volume of the solution of the original amount? It's 15. And of the new one, it's X. And so together I have 15 plus X. That's how many milliliters. Okay, that's how much I have if I measure it. Huh? Yeah, now we're going to solve it. So percent juice, right? How do you know how much percent, what percent of juice there is? Well, that's the amount of juice divided by the total solution, right? So if I have 100 milliliters of a solution, 10 milliliters of it is juice, that's 10% concentrated. All right, so now I need my fruit juice to be at 35%. So I need that to be 35%, which is 35 over 100, is equal to the amount, 15 times 0.10 plus 0.65x over the total 15 plus x. Okay, so the amount of juice over the total solution. All right, now we're going to cross multiply this. So I'm going to get 35 times 15 plus x is equal to 100 times 15 times 0.10 plus 0.65x. Now I do some major distributing, and I get 525 plus 35x equal to, trust me on this, when we multiply, it's 150 plus 65x, okay? 0.10 times 100, it'll be 150, okay? So now, this is, when I subtract 150, it's 375 is equal to 30x. We're almost done. Divide by 30, divide by 30, x is equal to 12.5. Okay? So basically, I need to add 12.5 milliliters of the 65% solution. All right? So with that, I will see you all after break. Have a fantastic break.